Good afternoon, students. We'll start with the today's lecture. Okay, already we have started with frequency response analysis. We have seen the introduction, correlation between time and frequency response, Bode plots we have seen. Then yesterday we have seen what is the difference between all pass system and minimum phase systems, right? Then calculation of a transfer function from the magnitude plot or experimental determination of transfer function, that also we have seen, right? Then next, actually this chapter is over, but I will be solving one more different variety of problem, right? That is numerical on board plot to determine the value of k. Means gain margin and phase margin will be given. We have to calculate the value of k. How to do that? We'll see through this numerical, right? Okay. The open loop transfer function of a system is g of s, that is equal to k divided by s into 1 plus s into 1 plus 0.1 s. Determine the value of k such that gain margin is 10 decibels and phase margin is 50 degree, right? 50 degree it should be, right? 50 degree. Okay. Gain margin is 10 decibels and phase margin, we have to calculate the value of k. What is the value of k, right? This is one variety of problem, right? This problem we have not solved earlier, right? K was having some value 2 or 20 something like that, but here we have to determine the value of k. How to do that using board plot, we'll see, right? Okay, we'll start as usual, right? First we'll get the magnitude plot table, right? So first magnitude plot table. Yes, initially we will assume k value as 1. We don't know what is the value of k. Let us assume k equal to 1 and we will continue, or else we will neglect this value of k. We'll assume k equal to 1 or else we will neglect this, right? Okay. So neglecting k or taking value of k as 1. Let me write this statement. Neglecting k, that is value of k, we'll assume it to be 1. And we'll continue, right? And we'll draw the board plot. If g of s is equal to, if k is 1 divided by s into 1 plus s, 1 plus 0.1 s, you can draw the magnitude plot and phase plot very easily, that board plot, right? If k is 1, right? We'll continue. Later on, what changes we have to make in order to find out the k value, we will see that, right? So we have taken k value to be 1, right? Okay. So let us start with the magnitude plot table, right? Okay. Then we will construct first serial number first. Next factor. Which are the factors, right? Then corner frequency. Simple poles are there, so we will be getting corner frequencies. Then slope contribution by every factor. The slope contribution, or simply the slope contribution of slope by every factor. Then cumulative slope. These all steps you know, but you don't know how to calculate the value of k. That we will take up at the end. First we'll do this numerical, right? You have to do this cumulative slope. The nature of magnitude plot. Or response also I can say. Okay, we'll take up one by one. First, yes, we have assumed k equal to 1, right? We have assumed, right? So neglect where value of k equal to 1. It is not there. Let me take k equal to 1. Corner frequency will not be there. No slope, cumulative slope. So 20 log k. 20 log 1 is 0. So 0 decibels. This is the reference line. If k is neglected, means it is 0 dB will be the reference line. No need to do this. We can neglect this first row itself. But let me take it, right? A reference line. But this statement is very important. Neglecting neglecting k, that is value of k equal to 1, right? We will make this assumption, right? Assume. I'll write assume, right? We'll assume. The next, whether I should take, next I have to take the pole lying at origin 1 by s. So second we will be taking 1 by s factor. This is the pole at origin. There will not be corner frequency. Slope contributed by this pole at origin is, you know this, minus 20 dB per decade. This is the contribution of slope. Cumulative slope, right? So previous there is no slope. This plus minus 20. So it is this nothing is there, means 0. 0 minus 20. So I will be getting minus 20 dB per decade. So what I have to write, let me write the comment later, or else let me write it, no problem, or else let me leave it. Let me go to the third step. I'll write the comment later. Okay, next, whether I have to take this simple pole or this simple pole, let me check it. 1 divided by 1 plus s I should take, or 1 divided by 1 plus 0.1 s. Let me check it. Right, what is the 1 plus t1 s? So 1 radians per second. Omega c1 is 1 by t. So 1 radians, from this I am getting 1 radians per second. Then from this what I will be getting, let me check it. 1 plus t2s. If it is t2 means what will happen? 1 by t2. 1 by means 10 radians per second I will be getting. So it should be in the increasing order of corner frequency, this corner frequency column. So first I will be taking 1 radians per second, then 10 radians. So I will be taking 1 divided by 1 plus s, this factor. 1 divided by 1 plus s. So what is the corner frequency? So t1 is 1 plus t1s. T1 is 1 here. So omega c1 equal to 1 by t1. So 1 by 1 is 1, 1 radians per second, right? So if this is a simple pole, so it will contribute minus 20 dB per decade. So previous slope, cumulative slope is minus 20. So present slope due to this factor is minus 20. So add both. So minus 20 plus of minus 2. So it is minus 40 dB per decade. Okay. I'll write the comment later. Last factor. Fourth one. 1 divided by 1 plus 0.1 s. So 1 plus t2s. What is t2 here? T2 is 0.1. So omega c2 is equal to 1 by t2. 1 by 0.1, right? It is 10 radians per second. Is it fine? Okay, due to this simple pole, it will contribute minus 20 dB per decade. This is the slope contribution by this factor. So previous cumulative slope is minus 40 and present due to this factor is minus 20. Add both, minus 40 plus of minus 20. So it is minus 60 dB per decade. Okay, let me write the comment here. So it is a straight line of this pole at origin will give me the initial slope of the magnitude plot, right? It is a straight line of slope. It is a straight line of slope minus 20 dB per decade passing through 0 dB reference line, passing through 0 dB reference line at omega equal to 1 till the corner frequency of, it is corner frequency here, it is 1 only, right? Luckily it is matching here, till omega c1 corner frequency equal to 1 radians per second. Yes, okay. Then next comment for the third factor. It is a straight line of slope, minus slope is cumulative slope is minus 40 dB per decade, minus 40 dB per decade after it has stopped at corner frequency, right? After omega c1 equal to 1 radians per second till the next corner frequency 10 radians per second, till omega c2 equal to 10 radians per second. Yes, 1 to 10 it is 1 decade, luckily, right? Okay. The next, it is the last comment will write, it is a straight line of slope. What is the slope? Minus 60 dB per decade, minus 60 dB per decade after omega c2 equal to 10 radians per second till infinity, because I don't have any other factor, so till infinity, right? So magnitude plot table is ready. Next we'll construct the phase plot table. So replace s by j omega. So we have assumed k to be 1, right? If I take k also, it doesn't affect for the phase plot actually, because let me check it, right? Let me replace s by j omega. So g of j omega is equal to k. Let me take k here. We will not neglect k here. K divided by s is nothing but j omega into 1 plus s, 1 plus j omega into 1 plus 0.1 s, 1 plus, sorry, 1 plus 0.1 s, 0.1 s is j omega. Okay, we are replaced, right? Okay, next we'll find the angle, that is phi, phase phi, right? So angle of g of j omega, okay, I can write it as k plus j0. Angle of k plus j0, it is 0 degree. Contribution numerator, right? It is 0 degree. Then angle of j omega, it is on j omega 90 degree, right? Then this one, tan inverse of imaginary part by, so tan inverse of omega I will get from this. So tan inverse of omega by 1, I will write only tan inverse of omega. Is it fine? Next, tan inverse of imaginary part by real part. So tan inverse of imaginary part is 0.1 omega by 1. So tan inverse of 0.1 omega. 0.1 omega. So finally the phase what I got is, take all these things to numerator. So minus 90 degree minus tan inverse of omega minus tan inverse of 0.1 omega. So this is the phase. So let us construct the phase plot table here. So for various values of omega and phi. Phi equation is this. This is phi, right? So no need to write. If you want, you can write. So let me start with 0.1. Then next, we should include all the corner frequencies. So 1 radians and 10 radians I have to include compulsorily. So 0.1 to 1. Let me take middle point 1, 0.5, then 1. This is one corner frequency. Let me mark it here. This is corner frequency. The next corner frequency is 10. Between 1 and 10, let me take 5. Right? 10. This is corner frequency. We have included all the corner frequencies. Then 10 after 10, directly will go to 100. Then to infinity. You can skip this 100, no problem. 10, then to infinity. So make equation of the phase phi in your calci. So I am making the equation here. This equation minus 90 degree. So minus 90 minus tan inverse of open bracket alpha a. So, omega means here I will be taking a, alpha a, pink letter is there, right? Instead of omega I am taking a in calci, minus tan inverse of open bracket 0.1 into alpha a, close bracket. So I will calculate what is the first value of omega. It is 0.1. I will give 0.1. So I am getting it as minus 96.28. So let me round it, minus 96 degree. 0.28 I am not writing, right? This is over. Next for 0.5 we will write. So what is for 0.5? I am getting minus 119 degree. Minus 119 degree. Next for 1, let us calculate for 1. So minus 140.71 means minus 141. Minus 141 degree. Next for 5, minus 195.25. So minus 195 degree. Then for 10, so minus 219 degree. Then for 100, so minus 263.71 means minus 264. Then for infinity, so we'll take the very huge value, 1 followed by 10 0 something like that. So it is near to minus 270 degree. So minus 270 degree. Okay, we have magnitude plot table and phase plot table. Now we can go for construction of Bode plot, right? So determining the value of k we will see later after constructing the Bode plot, right? We have to, in this problem we have to determine the value of k, that we'll see it, right? So I have the Bode plot here, sorry, a semi-log sheet. Okay, so we'll try to construct it. Let me roughly, we'll see here, see here, 1 minute. Where is the marker here? Okay, it has there. Okay, now 0 dB is the reference line. From 0 dB it is there. Initial slope, it is straight line of minus 20 dB per decade, means it has to go to plus 20. So I'll require plus 20 here, right? Okay, fine. I require only 1 unit above, not more than that. Below we will take, right? Okay. First we'll draw the magnitude plot. So let me take the values if it's possible, or else I'll take here only. So I'm taking, actually I can write here, you can take it here. If people have space here, you can take it here, but I am writing here 0.1. This is 1 log of omega 1, and this is 10, 100, sorry 100, 10, 100. Next 1k means 1000. Next 10k, 10,000, right? So this is log of omega. Log of omega. I have taken the scale. Is it fine? Okay. Next we will take the scale for magnitude plot. This is m in decibels. So m in decibels. So this is for magnitude plot. We'll see here, right? So scale will take. So scale for magnitude plot. So 1 division or 1 centimeter from here to here, 1 centimeter, or 1 division also you can call it as 1 division, that is equal to 1 centimeter. It's left you, right? It is equal to how much? Let me take it as 20 dB plus 20 dB. So one subdivision is how much? Let me, one subdivision is equal to how much? 20 divided by 5, because 5 subunits are there, 5 subdivisions. So divided by 5 means 5 4 means 4 decibels. So this is the scale for magnitude plot. So I'll take plus 20. I'll start from plus 20 because that is sufficient for us. Plus 20, 0 dB, minus 20. Let me stop here, minus 40. If I want more divisions, I'll be taking, or else I'll stop here. So 0 dB is my reference line for magnitude plot. So this is my reference line for the magnitude plot. Right, reference line is over. Next, let us have a look at. So this is over. Next, it is a straight line of slope minus 20 dB per decade, passing through omega equal to 1 till omega c1 equal to 1 radians per second. So minus 20 dB per decade, right, slope. So omega equal to 1 is here, and corner frequency is also same. Omega equal to omega c1 here. So let me write it here. Omega equal to omega c1, that is equal to 1 radians per second. Corner frequency, right? So omega c1, omega equal to omega c1, that is equal to 1 radians per second. It is same here. So minus 20 dB per decade here at passing through this 0 dB reference line at omega equal to 1. This is the point, right? So this is the point. So let me come out and use the scale. So I'll just mark these points, this one and here plus 20 dB, right? So let me join it using the scale. So let me keep this, keep it. Yes. If it's possible, let me zoom it. Yes, I'm zooming it. Okay, where is that? It will go off. Okay, fine, no problem. Okay, I have zoomed it. So let me take this straight line to join these 2 points from here to here. Right, slightly it should come below. It has to go up. Okay, somewhat. Okay, let me change the ink color. Yellow would be fine, I think. Wait, let me increase it. Okay, yeah, I hope this is fine, I think, right? So it is a straight line of slope minus 20 dB per decade. It has to join here, right? Slightly I will extend it. But this is extending here. Let me shorten it. Okay, I hope. Okay, let me. This is sufficient, I think. Okay, fine. Let me switch back. Yes, it is fine, right? So let me change the ink color. So slope is minus 20 dB per decade. Minus 20 dB per decade at passing through omega equal to 1 at 0 dB reference line till corner frequency, it is same till here only, right? Next we'll go back. This is over, right? Let me change the ink color. So this is k equal to 1 is over, this is over. Next we'll take this factor 1 divided by 1 plus s. It is a straight line of slope minus 40 dB per decade after omega c1 equal to 1 radians per second till 10 radians per second. Minus 40 dB per decade, 1 to 10. Minus 40 dB per decade. So 1 is here, 10 radians is here, right? This is 1 decade anyhow. Corner frequency is also same here. So it is equal to omega, that is equal to omega c2. Corner frequency, that is 10 radians per second, right? Right? So 1 to 10 is 1 decade. So minus 40 dB per decade. Now I am at 0. So minus 20, minus 40 I will come here. Right? From 1 to 10, it is 1 decade. So let me mark it here. So these 2 points. From this I will join it. So let me come out of this PPT. And let me try to keep this. Okay. So keep it. Yes. Let me join using the straight line. Let me take the straight line. Here it is. So from here, yes, 1 minute. Slightly I will adjust. Okay, slight variations will be there. So if anybody is drawing according to the scale, you can proceed and tell me the value later. So wait, let me change it to yes. I think this is fine, right? Weight is too much, I think. Okay, fine. This I have to take slightly up. Okay, fine. So we'll switch back. So it is a straight line of slope minus 40 dB per decade. Let me change the ink color. So this is straight line of slope minus 40 dB per decade after 1 radians per second till 10, 1 to 10, right? This is minus 40 dB per decade, over. Third factor is also over. This one, next last factor. So we'll proceed with this. So it is a straight line of slope minus 60 dB per decade after 10 radians per second till infinity, right? So next we'll take minus 60 dB per decade. So now I am here. So minus 60 means, so 60 dB I have to come, 20, 40, 60, here it will come, right? So minus 40, this is minus 60, minus 80, right? 1, 20, 40, 60, minus 100. So I have to come 60 dB down. So for 20, 40, 60 dB down, I will mark it here. But 1 to 100 is 1 radian, sorry, decade. So mark this point here. Because I have to mark the slope for decade, right? 1 to, sorry, this is 10 to 100. 10 to 100 is 1 decade. So this point and this point I have to join. Now it will be, slope will be 60 dB because I have come 60 dB down, right? So let me join it. Keep this. Let me take the line here. From this point, I will join to this point here. And I can extend also because till infinity, right? Till infinity means I can extend. Yes, let me change the color. Wait. Yes, that is fine. Okay, next I'll switch. So from here to here, but till infinity means I am extending this magnitude plot, right? So it is minus 60 dB per decade. 60 dB per decade after omega c2 equal to 10 radians per second till infinity. So it is going like this. So magnitude plot is over. So magnitude plot is over. Next we'll go for phase plot, right? Okay. Till here I have how many divisions? Let me start from bottom. 1, 2, 3, 4, 5, 6. 6 divisions, 7 divisions. I have 7 divisions. Okay. Let me choose the appropriate scale for phase plot. So here it is starting from minus 96, right? So let me take the scale. Let me start from minus 90, right? Minus 90 degree to minus 270. So let me take one division equal to let me check it. 90 plus 30, I will go on adding 90 plus 30 plus 30. So I think that is sufficient. I think 1 division equal to 30 degree or 15 degree. 1 division equal to, let me take 30 degree, right? So minus 90, 90, 100, 110 degree. Is it fine? 100, 110, 100 and plus 30, 140 plus 30, 170. Something I'm doing wrong. Check it. 90, 100, 120, right? So 90 plus 30, right? So 90, 120. Please, if I'm making mistakes, please correct me, right? 120 plus 30, it is 150. Here it is minus 180. So 180 degrees reference line. So I should get this also. Minus 210. 210 plus 30. 30 plus 10, 40. Then 270. So 1, 2, 3, 4, 5, 6. That is 6 divisions are available, right? So 1 division equal to 30 degree will take the scale. So let me write the scale here only for phase plot. Phase plot. So 1 division equal to 30 degree. So 1 subdivision equal to 1 subdivision 30 divided by 5, 6 degree, because 5 subdivisions will be there. So divided by 5. So 5, 6 are 30. So 6 degree. Okay, this is for phase plot. Next, we'll choose the scale starting from below, right? Or else from top, we'll select 1, 2, 3, 4, 5, 6 here. Is it fine? Minus 90, 100, 120, 120 plus 30, 150, 180, 210. Here it is. 210 plus 30, 240. This is 270. I cannot write it here. Let me write it here only. Minus 270. Okay, here. This one, right? So actually people should write here, but I'm writing here because this is not permitting me to write here. Phase phi in degrees. Phi in degrees. This is phase phi in degrees. So this is y-axis. X-axis scale is log of omega. We have written here, right? Okay, we'll continue. So we will mark. Let me take the snapshot of these angles. I will not refer, so I will take the snapshot in my mobile so that I can have a ready reference there. Yes, I have taken the snapshot. I will refer this and I will mark all the points there at a time. Is it fine? So I have taken the snapshot here. So let me mark minus 180 degrees the reference line for the phase plot. So draw the reference line for phase plot. This is the reference line. Next, I want minus 96 at point 1. This is point 1, right? Point 1 minus 96. 90, 96 will come here because one subdivision is 6 degree, right? So I will mark this point here. Keep it. What happened? Okay. Point 1 minus 96 here. Next, point 5, 100 and minus 119. Point 5, 2, 3, 4, 5. Point 5, 119 means 120 is here. So 190, let me mark it 120. No problem, nothing will happen, right? Next, at 1 it is minus 141, 120, 141, right? So this is 150. 150 minus 6, 144. 144 means 141 will come somewhere here. Is it fine? Okay, 141. So at 5, right? Sorry, at 1. This is 1 is here. So 141 means 150. 150 minus 6. 140, 144. 141 will come somewhere here. Let me mark this. Is it fine? What is happening? Okay, fine. I have marked it. Then next at 5. 5 minus 195. 5 is here. 190, 180. 186. 186 plus 6. How much it is? 186 plus 6, 192. But 195 I want. 192. Now 195 will come somewhere here. Right? Let me mark it roughly. Next. This is 5 minus 195. This is over. This is at 5, right? Okay, fine. Next 10 is minus 2 at 10 minus 219. This is 10 minus 219 means minus 219. 210, 216, 219 will come somewhere here. So earlier this has gone. I don't know what is happening. Why this should not go actually. Once again I have to mark here. 5 minus 195. 5, 180, 180, 186, 192, 195. Somewhere it will come here. Right. Let it. 10 is over. Next 100 minus 264. 100 minus 264. 270 is here. Minus 6, 264, right? Here. One division, right? From here to here. Minus 270 is this. Minus 6 means minus 264. Is it fine? Okay. Next we'll join. I'll change the ink color. Draw. You don't use the scale. Use the smooth curve. It should be a smooth curve joining all these points. You should not use the scale. I think this is correct, right? 1, then 5. Yes, it is there. After 1 I have taken 5. It should not go like this. Don't draw like me because I am unable to draw here. 264 at 100 it will come here. So slowly. Yes, at then it will join minus 270 degree. So this is phase plot, right? So phase plot. Okay, what they have given. So magnitude plot is ready, phase plot is ready. So what they are telling, calculate the value of k for gain margin equal to 10 dB and phase margin equal to 50 degree. So we'll take this and they will take this data, gain margin and phase margin, and we'll try to calculate the value of k, right? So one thing you should observe that the value of k we have neglected in magnitude plot. So the value of k affects only magnitude plot but not the phase plot, right? So the value, let me write one sentence here. Value of k affects magnitude plot, but it does not affect phase plot. Please keep in the mind, right? It does not affect the phase plot, right? So and we'll take these values, gain margin 10 decibels and phase margin 50 degree. Let me write somewhere. GM is 10 dB. So let me write somewhere here. Gain margin equal to 10 dB they have given. Then phase margin is 50 degree. So concentrate now how to calculate value of k. We have to calculate value of k, right? And we know that the value of k affects only the magnitude plot but not the phase plot, right? Okay. So you can observe here 0 dB was the reference line, right? So but they are telling gain margin is 10 decibels. Is it fine? Gain margin is 10 decibels. Is it fine? Okay. And one more thing, phase margin is 50 degree, but it is not affecting phase margin. Value of k is not going to affect phase margin. So this is the phase plot. It is crossing this reference line here at this point. So you will read this corresponding frequency, right? So it is not going to affect, right? So wherever the phase plot crosses the reference line minus 180 degree, that gives me what? Phase crossover frequency, omega pc. So what is that phase crossover frequency? We will see here. What is that? Omega pc. Here it is. Almost roughly 4 it is coming for me. Right? See, phase plot is crossing this minus 180 degree line here. So minus 180 degree. So corresponding frequency is omega pc here. Is it fine? So let me expand. No, right? Right? This will give me omega pc. What is this omega pc value? Let me write it here. Omega pc is how much? Read it. So it is 4 radians per second. I am getting 4 radians per second. This is omega pc. Is it fine? Okay. because value of k does not affect the phase plot, but it affects the magnitude plot. Whatever, this is the plot without k. Let me write it here. This magnitude plot is neglecting k, or plot magnitude plot without taking into account the value of k, without k. If with k means there will be a slight some difference, it has to shift, that shift we have not taken care, right? So but anyhow the value of k does not affect the phase plot. So from this we found out for phase crossover frequency omega pc. We will make use of this data later, right? Then gain margin is 10 decibels. Okay, from 0 dB reference they are telling gain margin is 10 decibels, right? So here the reference line is 0 dB, so I have to come 10 dB down, so that gain margin is 10 decibels, right? So if I measure the gain margin below, it is positive. If I measure gain margin above reference line, now reference line is 0 dB, but we have not taken into account the value of k. We'll see it later, right? So let me draw for 10 dB. So one subdivision is 4 dB. So 4, 4, 8. Next 10 will be coming here, right? This will be my reference line. Not reference line. Gain margin is 10 dB. Let me draw it here. This is 10. 0 minus 10. This is nothing but G, because GM equal to 10 dB, right? So from 0 dB I come 10 dB down. So this is GM, gain margin. Gain margin they have given, it is 10 decibels. And if I measure gain margin below the reference line, it is positive. So plus 10 dB, it is correct, right? Whatever I marked, their gain margin is 10 decibels. So in order to calculate the gain margin, right, we take the help of phase crossover frequency. So gain margin, phase crossover frequency will give me gain margin, right? I hope you know it, right? And in order to calculate phase margin, we will make use of gain crossover frequency, vice versa, right? So gain margin, this is the line I have drawn. Then omega pc, this is the phase crossover frequency wherever the phase plot is crossing. So extend this so that it cuts the magnitude plot here at this point, and this reference line 10 dB, because gain margin is 10 dB means it has to cut here, right? So this line and this line, don't take this 0 dB, you will take this 10 dB, because gain margin from here to right. So 10 dB, this should be the thing. So let me, 1 minute, I think I'm making some mistake or something. Okay, this is fine. Phase crossover frequency, it cuts here, and this is, if I take this as reference line, so this is the thing, fine. Here it cuts here. 1 minute, let me check it. Here to here, right? So it is 20, but I should take from here to here, 10 to, fine. Okay, let me choose some other color. Green color I'll be choosing. So this phase crossover frequency I am extending so that it cuts the magnitude plot here at this point, right? So this is without k. With k means there will be some shift will be there. So, and it is this 10 dB, because gain margin is 10 decibels, right? So I'll mark this point. This is A and this is A dash. Let me call it as A and A dash. The shift is, don't take this 0 dB as reference line. Now reference line has shifted to 10 dB, right? Because gain margin is 10 decibels. Because this plot has to shift 10 dB up, so that I will get the plot with k, the effect of k, right? This has to be shifted. So this has to be shifted by what amount? From A to A dash. This is A and this is A dash. A to A dash, there should be a shift. So let me read out this value. What is that? From here to here. So let me change the ink color. This is A to A dash. We'll read out this. So shift is in the upward direction, but it is right, A to A dash. I have to shift this magnitude plot from A to A dash. It has to cross this phase plot, sorry, magnitude plot should cross this 10 dB reference line here, right? So this shift is how much? Let me read this from here. Here it is minus 10. Here it is roughly I am getting here, but it should be exact actually. So minus 20. How much? Minus 24 here. Minus 24. Minus 24 dB. Minus 24 minus 10. Here it is minus 24. Here it is minus 10. So let me take the difference. 24 minus 10. How much? 24 minus 10. 14. So 20 log k, the shift 20 log k is equal to 20 log k, because I want to find out it is equal to, if the shift is in the upward direction from here to here, the magnitude plot is shifting in the upward direction. If the shift is downward, I should take negative. If the shift is upward, I should take positive. So how much? 24 minus 10, totally 10 decibels, sorry, 14 decibels, 14 decibels, right? Whatever I am getting by drawing the plot, I am doing this, right? So let me calculate here. 20 log k equal to 14 dB. Okay, 20 log k, let me write it here. 20 log k equal to 14 decibels. This is from plot, right? From magnitude plot. Let me change the ink color. This is not suitable. Next, this is base 10, right? 20 log k. Then log k to the base 10 equal to 14 by 20. 14 divided by, if you are getting some other value other than 14 dB, you can tell. I am getting 14. If anybody has drawn, please tell that value, right?
I
am
guess
getting,
it will come 10, sir.
It will come 10 for, yes, 10 is correct. Actually, textbook answer is 10, but I have drawn the rough plot. Okay, your friend is telling 10, so for me it is coming 14, because I on the pen and paper I had to draw, so it is coming 10 for frame size. So let me take 10 only, right? So 10 dB. So 20 log k to the base 10 equal to, I am getting 10 decibels, but I am getting 14, but let me take 10 because your friend has drawn it. It will be correct. So this is from magnitude plot, So log k to the base 10 is equal to 10 divided by 20. So 10 by 20. So I'm getting 0.5. So which implies, what is the value of k? K is equal to 10 to the power of 0.5. So 10 to the power of 0.5. So I'm getting 3.16. K value is 3.162. This is the value of k. Is it fine? K equal to 3.162. You can check in the textbook, they are getting the same thing. So 20 log k equal to 10 dB. Whatever friend told is correct, because I am drawing that magnitude plot roughly 10 dB. So 3.162 is the value of k. It is fine for gain margin of 10 decibels. This is for gain margin of 10 decibels, whatever we have calculated, right? This is for gain margin of 10 decibels. So the value of k for gain margin of 10 decibels is 3.162. For, let me write it here, for gain margin gm equal to plus 10 dB. Okay, let me go to the question. For gain margin of 10 dB, the value of k is 3.162. Still second part of the question is there. For phase margin of, please somebody mute yourself. Second part, for phase margin of 50 degree. Next, we'll go to the plot here. For phase margin of 50 degree, what is the value of k? I have to find out. For gain margin of 10 dB, we have found out it is 3.162 we got. For phase margin of 50 degree, how much, what is the value of k? We'll calculate. So phase margin is 50 degree. So if I measure, this is minus 180 degree is the reference line. If I measure above, it is positive. If I measure below, it is negative. So I want 50 degree means plus 50 means above I should measure, right? So observe here where I should get. This is reference line is minus 180. So 50 degree up I should go. So minus 180 plus 50, let me subtract it. So minus 180 plus 50. So I will get minus 130. At minus 130 I will mark. This is minus 120. Minus 120, 1 division 6 degree. Minus 126, 126, 132. 132 is 130 I want. So let me mark it here. Right, let me mark it here. Let me take yellow color only. So 126, 132. So roughly I will get here. You mark it exactly so and help me out. So, and this line from here, let me take it down. This is minus 180 and this is minus 130. They have given phase margin is plus 50 degree. So this is 50 degree, right? From here to here. So phase margin is plus 50 degree. It is correct, right? So we have to make use of this phase margin. They are telling phase margin is 50 degree. At this value, we have to find out At this value, we have to find out what? Value of k, right? So what is this phase margin? How do we calculate phase margin? By taking the reference of gain crossover frequency. So let me extend this so that it will give me gain crossover frequency, omega gc. Let me extend this. So it is cutting here, this reference line here. Sorry, I should go on this line only. I should not change the direction. So it is cutting the magnitude plot as well as the reference line, right? Is it fine? So 1 minute. Okay, what is that shift? I had to note down. Yes, fine. It is intersecting this 0 dB is the reference line. 1 minute. Yes, phase margin is 50 degree. I am taking this phase margin. I am extending so that it will give me omega gc. What is omega gc? Let me roughly write it here. What is omega gc? I am getting omega gc is equal to, here I am getting 7 radians per second. Anybody is getting some other value, you can tell me. I am getting omega gc equal to 7 radians per second and omega pc 4 radians per second. If any other values, I will write it here, whatever you get. So again crossover frequency, and observe here.
Sir, it's not 7, sir. It should be 0.7, sir.
Yes, yes, thank you. Because 0.1 to 1, it is 0.7. Yes, 0.7. Thank you very much. 0.7. Because scale is 0.1 to 1, this 7 means it is 0.7. It is 0.7 radians per second. Thank you. 0. radians per second. So I am getting omega gc. Let me write it here as 0.7 radians per second. And omega pc already we have calculated. I am getting 4 radians per second. Okay, I have extended. It is intersecting this reference line here. 0 dB is the reference line because for phase plot, phase plot is not at all going to be affected by the value of k, right? So 0 dB will be the reference. Don't consider this 10 dB as the reference line. So from here, this point, let me call this as C. Then it is intersecting, let me call this point as D, C to D. From here to here, this is C. So this value, let me draw it here. And this distance, only this much. So C and C dash, or C to D or C to C dash. So shift is upward. If the shift is upward, it is plus. If the shift is downward, it is minus. So it is plus. So this magnitude plot, if the phase margin is 50 degree, the magnitude plot should be shifted from C to D, right? So 20 log K is equal to, let me go to that 20 log K. How much will read it? Here it is 0 dB. At D it is roughly, what you are getting, you tell me. For me, I am getting one subdivision is how much? 4 dB. So it is 4 dB I am getting here. Totally 4 dB. Because shift is upward, so I am taking plus 4 dB. So 20 log K, whatever you are getting, you tell me, that I will write. For, let me write it, for phase margin equal to plus 50 degree, gain crossover frequency omega gc is 0.7 radians per second. I should have written in this also here, 0. radians per second. And 20 log k, what should be the shift of magnitude plot? 20 log k, it is equal to from C to D distance, right? So it is C to D. Just observe here, from C to D, it is, the shift is in the upward from C to D, right? It is plus 4 dB by reading from the graph. It is plus 4 dB I am getting. Any other value you are getting, you can tell me. If you are getting 4 dB, we will continue with this.
You can take 3, sir.
You are getting 3? Okay.
Yes, sir.
Okay, fine. 20 log k equal to plus 3 dB. So I will discard this, right? Okay, fine. To the base 10. Then log k, will calculate the value of k. Log k is equal to 3 by 20. So 3 divided by 20. So it is 0.15. Base is 10. So we will calculate the value of k. K is equal to 10 to the power of 0.15. Let me calculate 10 to the power of 0.15. So I am getting 1.41. 1.412. For phase, this is second part. For phase margin equal to plus 50 degree, gain crossover frequency is 0.7 radians per second, and 20 log k equal to plus 3 dB. This is from magnitude plot, or simply will say from plot, because we are using both, from plot, right? So this is for gain margin equal to 10 dB. What we are getting? Omega pc. Omega pc is how much? 4 radians per second. Whatever you are getting, you write it, right? So 20 log k equal to 10 dB. This is from plot, magnitude plot only, right? So k is 3.16. Let me cross verify the answers here. 3.162 and 1.412. In the textbook, yes, they are getting 3.162 for gain margin equal to 10 dB, for phase margin equal to 15 degree. Yes, 1 minute. I have made a mistake here, I think. Let me check it. Whether the distance is they are taking below. Whether it is below or up. I have taken plus 3 dB. No, they are taking minus 3 dB here. Minus 3. Why minus? Let me check it. Downwards they are telling. Oh, it is coming downwards. Let me check it. Yes, it is downwards. I have made a mistake because here this magnitude plot is at D. It has to come down by to C to be corrected, right? It has to come down to C. It has to come down like this. So it is minus 3 dB. Sorry. So yes, instead of plus 3, please take it minus 3. Sorry for that. So minus 0.15. 10 to the power of minus 0.15 we will do. 10 to the power of minus 0.15. So it is 0.707. 0.707. I will tell you why negative once again. Just observe here. We will go to the plot. See here. This phase margin is 50 degree, which will give me gain crossover frequency intersecting this reference line at point C and this magnitude plot without K at point D. So C to D, there is a difference here. So the magnitude plot which is at D, it has to shift to C. It is coming in the downward, it has to shift. The shift in the downward direction will take it as negative. The shift in the upward direction will take it as positive. But the shift is from D to C here. So we have to take it as negative here. So 20 log K equal to minus 3 dB. Minus 3 dB. I hope you are getting right. So this is one variety of problem. So when phase margin is given, this is the value of K. When gain margin is given, this is the value of K. When phase margin plus 50, value of K is 0.707. Yes, for gain margin of 10 dB, 3.162. For phase margin 50 degree, value of K is 0.707 we got, right? Okay, this completes. I'll stop recording.